We're now taking you out to the operations floor here in the office, and at this workstation, we call this workstation the CRS workstation, or console replacement system. Basically, it's a fancy word for NOAA weather radio, and this is how we monitor NOAA weather radio. This is an example of a weather radio that one may have at their home. You can pick these up anywhere. This one particularly is from Radio Shack, but any electronics store has these, and they keep you alerted to basically severe weather and any kind of weather information, or non-hazardous weather information as well. But this particular weather radio is broadcasting forecast information for our area, for the marine areas, for inland areas, and other hazardous weather information as well. Basically, what would happen in the event of a severe weather outbreak in the area, a warning would be issued from the office, and it would go into this system, and it would automatically tone alert these weather radios that you may have in your home or out portably in the area, but they would automatically go off and alert you of impending hazardous weather. But this is how we monitor the system here through this screen and this complex of equipment here in the office. We can change the information, change the order of the information, do all sorts of things with the broadcast cycle, basically, kind of like a mini radio station, if you will. So we have control of what goes over the air here and things like that. So this is how we monitor the NOAA weather radio system, and how we conduct weekly tests, things like that, along the system as well. We have 3 transmitters in the area: Brownsville, Pharr, and Rio Grande City. So we can broadcast out to majority of the population here in Deep South Texas through those 3 transmitter sites. And basically that's how our weather information gets out. It's the voice of the National Weather Service, and we can broadcast this information. It goes 24 hours a day, 7 days a week, all year round. We're now joined by Bianca here in the office. She's one of our volunteers here this summer in Brownsville. Welcome, Bianca, to Brownsville.
Thank you.
She's been interested in meteorology for quite some time, and she's volunteering her time here this summer. Tell us a little bit about what you're going to be doing.
Well, I've been researching about hurricanes, and I've been shadowing the forecasters here and learning about the different programs, like the hydrology program.
Okay. I guess some interesting things to take a look at over the next several weeks, but you have plans to head towards college later on this fall. Tell us a little bit about that.
I'm going to be attending Texas A&M University. I'm going to major in meteorology.
All right. Well, good luck with that. I guess once students go into the college atmosphere and they go into college, they can be part of a SCEP program, which is part of the National Weather Service. It's basically students like yourself get to come back for a summer at a local office and continue to volunteer their time, I guess, and get paid for it. And is that something that sounds like I guess you're going to be doing as well?
Yeah, I'm interested in doing it.
Okay, so it's great experience for those kids that are going to college as well. It's basically hands-on experience right here in the office, and allows them to see what's going on here in the office as well, and provide helpful help as well to the folks here in the office. Thanks for joining us today, Bianca.
You're welcome.
We're now joined by Wendy, one of our student volunteers here this summer in the office. Welcome to Brownsville, Wendy. Glad to have you here. Tell us a little bit about what you're going to be doing over the next several weeks.
Well, basically what I'll be doing this summer is maybe shadowing some of the forecasters and doing a little bit of research, and hopefully get to know more about the National Weather Service and what it's really about.
That's right. As part of the program, a volunteer, a student that's going into meteorology could volunteer some time at a local office. They really get to see hands-on what takes place in the office and what the forecasters and the different personnel do here in the office. You've had an interest in meteorology for some time. Tell us a little bit about what your plans are as we move towards fall and college.
Well, I'll be attending Texas A&M University at College Station, and I enrolled there. I have everything ready, and hopefully I'll stick with the meteorology program, maybe join the storm chasing team at A&M, and that's what I have planned so far.
All right. Should be some exciting times for you ahead, right? Looking forward to it. Thanks for joining us today.
Thank you.
Anthony joins us now. He's one of our student volunteers here this summer. Welcome to Brownsville, Anthony. You come from Puerto Rico, right?
Yep.
Okay. You're going to be doing some research here in the office this summer. Tell us a little bit about what that it means.
Well, the research is about to find a relationship with the hurricane tracks and the ENSO.
Oh, okay. So you're going to be just kind of doing some, looking at the numbers, I guess,
Yes,
how far along
statics. So,
historical records and things like that, right? Okay. All right. And I guess at the end, what happens if just kind of after the research project is done here? What kind of things will you expect to?
yeah, the finish of the research, I have to present in Puerto Rico University, and I have to make a paper. So that's what I'm doing.
Okay. Well, good luck with the project this summer, and thanks again for volunteering.
Thank you.
We're now outside here of the office here in Brownsville. We're joined by our Science Operations Officer, Doug Butts. Thanks for joining us today.
No problem.
We are going to be getting exclusive access to one of the most important pieces of equipment we have here as meteorologists at the National Weather Service, and that is the Doppler Radar. Doug is here to tell us a little bit about how important it is and how we use it here.
The Doppler radar is vitally important to the operations of the National Weather Service, Ryan. Inside the dome is a dish that is 28 feet in diameter and spins constantly, 24 hours a day, 7 days a week, and helps us as meteorologists to look out for bad weather.
All right. One of the important things it does is able to see rotation in, I guess, severe thunderstorms, things like that. So that really helps us to provide, warning information to our county warning area.
Right, and we're not only talking about the rotation inside severe thunderstorms and tornadoes, but we're also talking about the winds inside of hurricanes. We can see damaging straight line winds inside severe thunderstorms as well as get estimates on rainfall amounts and a whole host of information.
Right. I guess one of the important pieces of equipment we use here at the office, it's vitally important. We're going to take you up there right now and show you what's inside. Well, we're back up inside here, exclusive access to the Ray Dome here where our radar dish is housed, and Doug joins us as well again. The radar technology has been around, Doppler radar technology has been around a while, and here in Brownsville as well.
Yes, Doppler radar has been around since the late 70s actually, but the National Weather Service actually put it into use in the early 90s with a massive deployment nationwide of Doppler radars. Here in Brownsville, it's been installed since early 1995.
Okay. The radar technology has advanced over the years since then. Tell us a little bit about that.
As you're well aware, technology has advanced leaps and bounds since the early 90s. And the radar is no exception. When this was installed, this was the best we could get. Within the next year or two, we're talking 2012-2013 time frame, this radar will be updated to not only tell us whether or not we're seeing heavy rain, but whether or not it's snow or rain or hail.
Okay. Great information, and it's a great tool we use here at the National Weather Service office in Brownsville, and it's nice to see, get an inside look of how things work here in the office.
Well, we're once again joined by our intern, Aaron. And Aaron, we are out here in the upper air building, out away from the main National Weather Service facility here in Brownsville. And here in the upper air building, you've got this funny looking thing laid out here on the table. What exactly are we looking at this morning?
Okay, well, what we're looking at, the white thing over here is our weather balloon that we're going to fill up here in a little bit and send off with the radios on. But a little bit about the weather balloon, it's about 600 grams, and we fill it up with hydrogen. And when it's here in the inflation shelter, it used to be about 6 feet in diameter, but as it goes up in the atmosphere and the atmospheric pressure decreases, it gets to be about 20 to 25 feet. And when it gets up there and it gets really thin, that's when it bursts, and then it comes back down to Earth. And that's where the parachute comes into play. Parachute is part of the flight train. and we make sure that it's tied off to the balloon. So when the balloon does burst, it makes sure that the radiosonde comes gently back down to Earth, and sometimes it can be recovered.
Okay, so we're going to fill this large balloon up with gas, and we're going to tie the whole thing off with string and such. And the radiosonde that you mentioned is what we talked about earlier at the upper air cubicle, that small white box that has all the instrumentation on it to detect temperature, pressure, atmospheric moisture and stuff. And this whole contraption carries that package up through the atmosphere, and to the effect that we sound the atmosphere to figure out exactly what it's doing.
Right, it goes up to about 100,000 feet. And depending on the winds and such, as we go up in the atmosphere, it can get as far as 100 miles away from here.
Okay, great. Well, we'll come back out here with you in a little while, and we'll let this whole thing go, and we'll see what happens.
Sounds good.
Thank you. Well, we're once again joined by our intern, Aaron. And Aaron, I see the balloon is all tied off to the package out there, the radiosonde package, and so we're all set for a flight, aren't we?
We are.
Okay, so go ahead and let her rip there. I'll step out of your way. Well, unfortunately, that's all the time we have today for this virtual tour of your National Weather Service office here in Brownsville, Texas.
If you would like to visit us in person, feel free to give us a call at area code 956-504-1432. Also, don't forget to visit us online. Our website, weather.gov/RGV, and on Facebook, U.S. National Weather Service, Brownsville, Texas.
From all of us here at the National Weather Service office in Brownsville, including videographer Jim Campbell, I'm meteorologist Joseph Tomaselli.
And I'm meteorologist Ryan Vipon. Thanks for tuning in.